Planets elsewhere that there is life. Now, I know what you've seen, and there have been some 300 sightings since then. I've talked to those pilots, and they know they saw something, and their radar's locked onto it.
This grainy black and white streak is not a camera glitch. It is the first close image of interstellar comet 3I Atlas, taken from orbit around Mars. 30 million kilometers from Earth. 3 spacecraft pinned their cameras on a visitor moving faster than a rifle bullet. And what they saw does not match a single prediction. The nucleus is not a lumpy potato, the coma is not symmetrical, and the tail is pointing the wrong way. If the data hold, everything we thought we knew about how comets form around other stars just dramatically collapsed. It's a truly humbling moment in astronomy.
This video is sponsored by Upstream. Want to grow your YouTube channel faster? With Upstream, you can run a 24/7 live stream using your pre-recorded videos. Since live streams rank higher in search, you'll gain more views, more subscribers, and more revenue. And it's not just YouTube. Upstream lets you multi-stream to up to 10 platforms, design custom layouts that match your brand, and schedule your content so your channel is live even when you're not. Sign up free today with the link in the description, and if you decide to upgrade, you'll get 20% off your first month. Start streaming smarter with Upstream.
When the Atlas Survey Telescope spotted the comet on July 1, 2025, astronomers had 48 hours of arc to work with. The orbit screamed interstellar. Eccentricity 6.14, hyperbolic excess speed 58 kilometers per second, inbound from somewhere in Cassiopeia and outbound to Sculpture forever. Early spectra showed the usual suspects, water, CO, CO2, so the press release called it a carbon copy of Borisov. That was the safe bet, of course, given our limited prior experience with interstellar objects. Then, Mars got in the way. On October 3, 2025, the comet passed inside the orbit of Mars. NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and China's Tianwen-1 were all commanded to stop looking down and look out. The high-rise camera usually maps rocks the size of dinner tables. Suddenly, it had the monumental task of tracking an object traveling 45 times the speed of a Martian satellite. Engineers ditched the normal scan and stack routine, took a single 0.3-second exposure, and crossed their fingers. The raw frame looked empty until a sharp-eyed graduate student stretched the histogram and the nucleus popped. A cylinder 900 meters long, 200 meters wide, rotating every 3.7 hours, black as jet except where sunlight scatters off a razor-thin rim. No coma in the optical, yet infrared data from the same second shows 3,000 tons of dust every hour. Try explaining that with freshman physics. What the Mars orbiters revealed were not just details, but 3 major shocks. Shock 1, its shape. Comets are typically understood as rubble piles. Self-gravity demands a roughly spherical body once you pass 400 meters. Something this elongated should have spun itself apart. Shock 2, its color. The surface reflects less than 2% of sunlight, darker than charcoal, darker even than Oumuamua. While carbonaceous coating is normal, here there is no reddish tint, meaning no organics or they have been thoroughly baked off. Shock 3, the tail vector. Instead of pointing away from the sun, the dust lags 35 degrees behind the radius vector, as if the solar wind is blowing in 2 directions at once. Magnetized dust? Electrostatic lofting? Nobody has a working model. Distance is truly everything in astronomy. At Earth, the best adaptive optics gave a smudge 12 pixels across. From Mars, the angular size doubled and, crucially, the spacecraft were already calibrated for the red planet's dust. Thermal emission at 12 micrometers showed the surface swings wildly from 380K to 120K in one rotation, indicating no readily accessible volatiles, no insulating crust, just naked, refractory material. That extreme temperature swing would crack normal cometary ice in hours. Yet spectra still pick up gas. Conclusion? The volatiles are buried 10 meters down, released through a single vent no wider than a tennis court. A single jet is doing all the work, and because the jet is not on the rotation axis, every few hours the comet wobbles like a poorly thrown football. Oumuamua had no coma, no tail, pushed by a mystery force we still call non-gravitational acceleration. Borisov looked like a carbon copy of solar system comets, 2 kilometers wide, bright, gassy, tail for days. 3I Atlas splits the difference. The orbit says interstellar, the surface says baked dry, the gas says fresh interior. One object, 3 personalities. Modelers are already arguing this is the norm and the first 2 were outliers. If so, every comet we have studied from the Kuiper Belt may in fact be the genuinely weird one. Simulations run last week at the University of Bern show only 2 ways to get a cylinder this large. Option A, a catastrophic graze, where 2 exoplanetesimals brushed at 500 meters per second and immense tidal forces stretched them like taffy. Option B, a sublimative whittling, where a much larger body wandered too close to its parent star, lost the outer mantles, and the core eroded into a needle-like shape. Both scenarios need the system to be older than 8 billion years, metal-poor, and bathed in extreme ultraviolet. That significantly narrows the birth neighborhood to a handful of old Milky Way halo stars currently within 200 light-years from the Sun. We may never know which one, but the list is short enough to phone every theorist who modeled those systems. Every interstellar object is a free sample of exoplanetary material, but until now we had only 2 data points. Add a third that breaks the trend line, and suddenly the dispersion is huge. The carbon-to-oxygen ratio, the nitrogen budget, even the argon abundance can swing by orders of magnitude. That means the ingredients for habitable planets are not uniform across the galaxy. A few light-years to the left, rocky worlds may form with 50 times the cometary inventory of water, oceans hundreds of kilometers deep. A few light-years to the right, you get Mercury clones. 3I Atlas is a profound reminder that habitable zone is only half the story. The delivery truck matters. On November 2, the comet crosses Jupiter's orbit. ESA's JUICE spacecraft, originally designed for Ganymede, will slew its narrow-angle camera and try to track the nucleus for 3 weeks. If the rotation model holds, we will see the jet switch on and off as the vent enters sunlight, giving us a direct measure of internal pressure. Meanwhile, the James Webb Space Telescope has been allocated 6 crucial hours of director's discretionary time to hunt for argon and neon, noble gases that only stick to ice in the coldest, darkest parts of a protoplanetary disk. Detect them, and we have a precise thermometer for the birth cloud. Miss them, and the needle model gains a data point. Within hours of the image release, #AlienProbe trended on every platform. The coincidence with the US budget shutdown, NASA's newsfeed froze for 36 hours, fueled conspiracies. Scientists understandably shrug. The orbit is public, the spectra are public, the math is Newtonian. But the cylinder shape is pure catnip for speculation. The lesson? If you want to go viral, be dark, be fast, and be shaped like something humans already built. If you want to stay ahead of the next interstellar visitor, and trust me, there will be a next one, and the next round of conspiracy theories, hit subscribe and ring the bell. The algorithms think you're done after 3 minutes. Prove them wrong.
Hyperbolic objects are cosmic bullets we cannot dodge, but every close flyby is an invaluable rehearsal.
ESA's Fly Eye telescope, coming online next year, will scan the entire visible sky every 2 nights. The software pipeline, tested and refined on 3i Atlas, now flags anything with curvature greater than 0.05 arcseconds per hour. That astonishing sensitivity could spot a 10-meter interstellar boulder 3 days out, too late to deflect, but enough time to warn satellites to maneuver. One day, the warning may be for something bigger than a comet. I have covered Oumuamua, Borisov, and now this. Each one felt like science fiction delivered overnight. But 3i Atlas is different. It is ugly, it is broken, and in its very imperfection, it is absolutely perfect. Ugly because no textbook would print that shape. Broken because it should not survive a single perihelion. Perfect because it is the first time the universe has handed us a comet that feels genuinely real, messy, unpredictable, and nothing like the neat drawings in graduate lectures. If the next interstellar visitor is a sphere, I honestly will not trust it. So the first close image of 3i Atlas is not a smoking gun alien craft. It is something far weirder, a natural object that utterly refuses to act natural. A kilometer-long shard of another solar system, spinning like a propeller, leaking gas through a single hole, and teaching us that the galaxy's chemistry kit is far more eclectic than we dared believe. We are constantly learning that the universe is richer and stranger than our models can predict. So keep watching the skies, because the next parcel from the stars might be even stranger. If you learned something new today, like the video, share it with someone who still thinks all comets look like dirty snowballs, and I will see you in the next orbit.